Hi there everyone. So in this video we again looking at the derivatives part of calculus, but this time we're not going to be doing it from first principles, which is that long method. Instead we're going to be using a rule that makes it so much more quicker to find a derivative of a function. So let's have a look at this rule. Now there is a proof for this rule, but we're not going to go over that proof today. So we're simply just going to be using the rule. Okay. Now, the rule says that if you have a function of, or that's equal to x to the power of any number, any exponent basically, n being that exponent, then the derivative, which I failed to write here, there should be a line there, which the derivative of fx will then be equal to n multiplied by x to the power of n minus 1. So what this basically means is that exponent is being multiplied with the number in front of the x, and then it's being decreased by 1. Okay, so two things is happening. You're multiplying the number in front with the exponent, and then you decrease the exponent by 1. So if we look at it, a first example, here we have fx is equal to x to the power of 4. So if I want to apply this law, I need to multiply the 4 in front and then minus 1 to that exponent. Okay, so the derivative of this function is going to be, that's supposed to be an x. The derivative will be 4x cubed. Okay, so we multiply it in front, then we subtract 1 to that exponent. Now, even if there were multiple terms, for example, number 2, we have the function equal to 2x cubed plus 4x to the power of 5. So the derivative, which we write with an f and the line on top, is simply equal to that exponent multiplied by the number in front, and then we decrease the exponent by 1. So it's like you're removing 1x. Since there's 3 x's multiplied together, we're taking the 1x away, so there's only 2 left. Here we multiply the 5 by the 4, so that gives us 20. And then we decrease the 5 by 1, so x to the power of 4. Okay, there's 5 x's, you're taking 1 away. Okay, now so far we've just looked at functions that has fx. What if your function has y? How do you then write the derivative? Well, since the derivative is basically the gradient, we can say dy over dx. This is to resemble the difference of the y's over the difference of the x's. So it's the gradient. Okay, now 2, the exponent, multiplied by 3, and then we decrease 2 by 1. So if we had x squared, we will just have x. Okay, 1x. Now here, minus 5x, so the exponent here is an invisible 1. And if we multiply that with the negative 5, we still have the negative 5. But then we have x to the power of 0, right? So x to the power of 0 is just 1, so we just stay with the negative 5. Because once you multiply 1 with negative 5, it stays negative 5. Basically, I think about it like this. We have 1x, and the moment you take away an x, then we don't have any x's left. Okay. Now this number, the 7, doesn't have any x's to begin with. So once you differentiate, this will just fall away. So any constant just becomes 0. So the derivative of a constant is just 0. Okay, last one. Again, we have a y, so I'm going to say dy over dx. The derivative of y with respect to x. Okay, so again, multiply the exponent by the number in front. So 2 times 6 is 12. And then since we're removing 1x, we only have 1x over here. I don't have to write the 1 exponent. Now, if you look at what happened here, we had a 5x, and then we just wrote the negative 5. So the moment you just have an x, and you're taking that x away, you're just left with the number in front of the x. In this case, the number in front of this x is negative 1. Okay. Now, just like in the previous case where we had plus 7 as our constant, here we have pi, which is also just a number. In fact, the number for pi is 3,14 and a few other decimals. Well, a lot of other decimals. Anyways, since it's a constant, it becomes 0, and this is our final answer. And there you go. That's how to find the rule using, that's how to find the derivative using a rule. Okay.